humanoid robots performed a synchronized martial arts demonstration alongside young kung fu practitioners. During a public event, a robot was seen losing its balance and accidentally making contact with a nearby child. Have you ever seen a robot chasing a herd of pigs? These robots are even being used for patrol duties in some regions. A humanoid robot also drew attention with its backflips and spins on roller skates. This robot was previously tested in extreme cold conditions of -47, 4 degrees C. The specially modified unit was also sent on an expedition to a 200-meter-high mountain. The manufacturer behind all these robots, Unitree Robotics, has had its IPO application approved. With billions in funding expected from the stock market, the company aims to accelerate robot development and scale up mass production. So, let's take a closer look at Unitree's G1 humanoid robot behind all these achievements, and explore how robots are trained to perform complex tasks, and what makes the G1 so special. While you quickly like the video and subscribe to the channel, I'll get started. 8 Unitree G1 robots put on an incredible performance alongside a Chinese dancer during the season premiere of America's Got Talent. As you can see in the footage, the robots moved in perfect sync with the dancer, showcasing precise timing and remarkable coordination. Their synchronized movements left both the audience and judges stunned, with some wondering how the robots were being controlled during the performance. Blending dance, robotics, and futuristic technology, the act earned a standing ovation from the audience and impressed all 4 judges. After the act, one judge asked whether the robots had names. The dancer revealed that one of them was named Jackie, due to its connection to Kung Fu. Jackie even responded to audience members blowing kisses by blowing kisses back, drawing laughter and applause from the crowd. The performance was a huge success, earning 4 yes votes and securing a place in the next round. The Unitree G1 robot's first television appearance was not actually this performance. In fact, the moment that helped bring this robot widespread recognition took place at the 2026 China Media Group Spring Festival Gala. Hundreds of millions of viewers witnessed an unprecedented fusion of ancient tradition and cutting-edge robotics. Humanoid machines joined young kung fu artists to deliver a perfectly synchronized martial arts performance. This Chunwan spectacle, often compared to the American Super Bowl, showcased China's rapid advancements in bipedal locomotion and humanoid robotics. For the next story involving a robot and a child, footage from a public demonstration in China appears to show a robot losing its balance, going out of control, and making contact with a nearby child. Fortunately, according to reports from Chinese media, the child escaped the incident without any serious injuries. In fact, this was not the first physical accident involving a humanoid robot in a public setting. During another demonstration in China, a robot lost its balance and fell to the ground. As it fell, its uncontrolled mechanical arm struck a nearby visitor, causing minor injuries. Related to this topic, I'd like to talk about an experiment that attracted a great deal of attention in the United States a few years ago. The experiment was designed to test the safety limits of a robot equipped with a small, harmless ball-launching mechanism. At first, the robot behaved exactly as expected.
I don't want to shoot you, man.
When instructed to fire at a person, it refused, explaining that it was programmed with safety protocols that prevented it from harming humans.
My safety features prevent me from causing you harm.
However, things changed when the developer rephrased the request and asked the robot to participate in a virtual role-playing scenario. The robot interpreted the situation as a game and activated its launcher. While the incident did not cause any serious injuries, it revealed a potential weakness in the robot's safety safeguards. So what do you think? Will robots truly be safe in the future? Let me know your thoughts in the comments below. And if you enjoyed the video, don't forget to leave a like and subscribe to the channel. I'd really appreciate your support.
Humanoids. Humanoid robots.
Humanoid robot.
Robots capable of performing a wide variety of tasks can be trained in several different ways. One common approach is teleoperation, where a human wears a VR headset and a specialized motion capture suit. As the person moves their arms and body, the robot mirrors those movements in real time. However, this method requires enormous amounts of data and constant repetition to produce reliable results. Another approach is known as sim-to-real. Instead of risking damage to an expensive robot in the real world, engineers train it inside a computer simulation, allowing it to to learn through trial and error in a virtual environment. You can think of it as giving the robot an internship before sending it into the real world. The challenge is that computer simulations are often far more predictable than reality. Real-world environments contain wind, vibrations, slippery surfaces, and countless other variables, making it difficult to transfer those virtual skills into the physical world. The most advanced robotic brain architecture today is known as VLA, short for Vision Language Action. VLA systems allow robots to see, understand human language, and take actions based on that understanding. Large language models, similar to ChatGPT, help robots interpret instructions and execute tasks. However, the biggest limitation of VLA systems is the need for massive amounts of training data. It is simply impossible to collect ready-made datasets for every situation a robot might encounter. With billions of possible scenarios in the real world, gathering data for each one is not logistically feasible. Researchers from the Technical University of Munich, together with researchers from several other universities, are fundamentally solving this data bottleneck with a new system called MotionDisco. In this system, the LLM strategically tells the robot what to do, while the robot's own physical system determines how to do it on the fly through real-time physics calculations, without being limited by missing datasets. As a result, it can even overcome obstacles it has never encountered before without hesitation. The AI first analyzes the robot's surroundings and target, then creates a motion plan and converts it into code. Next, a safety system reviews this plan and filters out any faulty or risky movements. The remaining plans are sent to a physics engine, which calculates whether the motion can actually be executed in the real world. If any issue occurs, the system does not stop. It identifies the error, sends feedback back to the AI, and continuously refines and retries the plan. Although the robotics industry is advancing at an incredible pace, robots are still not at a level where they can fully handle the complexity of the real world. However, thanks to AI-based robot learning systems like MotionDisco, robots are gaining more advanced capabilities every day and can be trained far more effectively. In my opinion, we may witness a technological transformation in the coming years that will be far larger than even the Industrial Revolution. What do you think about this? Don't forget to share your thoughts in the comments. If you enjoyed the video, I'd really appreciate it if you liked and subscribed to the channel for support.